Dear students, we are going to continue our discussion on the air conditioning processes. In order for us to maintain a living space or industrial facility at desired temperature and humidity, it will require some processes. These processes is called air conditioning processes. These processes included simple heating, where this process will raise the temperature. Next we have simple cooling, where the temperature will be lowered. Another process is humidifying process. In this process, we are going to add moisture. Lastly, we have dehumidifying process, where some of the moisture content will be removed. Note that there can be combination of these processes. For example, heating and humidifying process, or cooling and dehumidifying. In order for us to analyze the desired air conditioning processes, we can obtain the information by either using equation method or psychometric chart. If we draw these processes on our psychometric chart, it will look like this. For simple cooling, starting from a point, it will move horizontally to the left. Meanwhile, for simple heating, it's going to move from a point horizontally to the right. Note that the scale at the psychometric chart is representing the dry bulb temperature. For humidifying process, it's going to start at the initial state vertically to the top. Meanwhile, for the humidifying process, it will be vice versa from the humidifying process. The movement will start from the initial state and heading to the bottom. Note that this scale on the psychometric chart representing the specific humidity. For heating and humidifying process, it will increase the dry bulb temperature and also the specific and relative humidity. Meanwhile, for cooling and dehumidifying, it will reduce the dry bulb temperature and the specific and relative humidity. In our analysis on the air conditioning processes, we are going to use the mass and energy balance, since the air conditioning processes will be modeled as steady flow processes. Therefore, we will always have the mass balance for dry air, the mass balance for water, and the energy balance. The mass balance for the dry air will be given by the summation for the mass flow rate for the dry air at the inlet is equal to the summation for the mass flow rate for the dry air at the outlet. This will usually constant throughout the process. For the mass balance for water is given by summation for the mass flow rate of the water vapor at the inlet is equal to summation for the mass flow rate of the water vapor at the outlet. Since we know that the specific humidity is the ratio between the mass flow rate of the water vapor with the mass flow rate of the dry air, therefore we can get the mass flow rate for the water vapor is equal to the mass flow rate of the dry air times with the specific humidity. If we substitute this to the mass balance for water, we are going to get this relation. Please note that the mass balance for the water is depends on the air conditioning processes. For the energy balance, it actually comes from the steady flow energy equation SFEE as being introduced in MEC 251. From the conservation of energy, we can obtain the steady flow energy equation. In most cases, we can neglect the terms kinetic energy and also potential energy, which leaves our steady flow energy equation to this expression. Again, note that the energy balance will also depend on the air conditioning processes.